Well, yes, I'm Lauren Gresh. I am a science reporter for The Verge, specializing in all things space, and I frequently write about the research that is headed to the International Space Station. So I'm particularly excited to be here at the ISSRD conference today. And I'm especially excited because we are on the West Coast. I'm from the East Coast, and our weather is not as fabulous as it is here right now. But how fitting that we're here in the Bay Area because of what we're talking about today, which is Silicon Valley. And this part of the country really represents, the hub of innovation, a community for entrepreneurs, and I think that's exemplified in who we have here on the stage with me today. A lot of people or a lot of companies wonder how they can leverage the space station or maybe think that they can't, but these companies are actually doing it and using space to either enhance their technologies or grow their businesses. And so I want to pick your brains about how you're actually doing that. So sitting next to me, I have Andrew Rush, who is the president and CEO of Made in Space. Then we also have Nick Elaine, who is the brand director for Spire Global. And at the end, we have Mark Fernandez, who has a very long title, the software payload developer of the Spaceborne Computer for HPE, which sounds very cool. So thank you so much for joining me today. So first things first, let's go through each of your companies, and I want to hear a little bit of background about how you guys are using the International Space Station and space. So Andrew, let's start with you. I mean, what you do is in the name of your company, so why don't you expand on that? You guys have the first 3D printer on the International Space Station. So talk a little bit about the history of why create a 3D printer for the space station? Where was the impetus behind that?
Yeah, absolutely. Thank you, Lauren, for having me, and thank you to the conference organizers. So from a broad perspective, Made in Space is founded on the vision of helping people sustainably live and work in space, and trying to address the fundamental barriers that have existed, since the 50s, in achieving that vision. And what we've kind of come down to are two things, really, like the economic incentive to go and stay, and the tools that we're going to need to go and stay. That's the sort of fundamental underlying vision that gets us up super early and keeps us super late, and then rinse and repeat, 5, 6, 7 days a week.
Right.
And we started with additive manufacturing on the International Space Station as this great foundational technology to really be sort of a meta tool that lets us create whatever we need, for in the environment. So sort of like going and settling the West and taking tools to build a new town. That's really what this technology, that's really what additive manufacturing and advanced robotics enables. And so those are the things that we've been focused on. And then building on that, we've gone in a couple of different directions that have very strong near-term commercial viability. One of those is building portions of satellites on orbit, like actually manufacturing and assembling large solar panels, large reflector arrays, or one day maybe enabling more cost-effective space stations for people to commercially and from a government perspective use. And the other direction is what we call space-enabled manufacturing. And this is doing manufacturing and processing of materials that in the space environment, in the microgravity environment, that because they're processed there, they have these really amazing properties that and they actually command a price that would support paying for launch, operation, and return, here on Earth and in existing markets. So really tying space back to the Earth and tying what we're doing on the ISS, to creating real benefit for people on the ground. And this all is enabled by the International Space Station and by the National Lab in particular. That without the ISS, without the National Lab, we wouldn't be here. We wouldn't have had these breakthroughs, and we wouldn't be able to, make small bets, succeed or fail. So far we've succeeded. And then keep growing and make bigger and bigger bets, and really see other people be enabled by that as well. And I think that's sort of like the fundamental beauty of the ISS and the National Lab is it externalizes a lot of support that we need, so that lets us do new science and create new business models that will expand the pie of launch, expand the pie of operations in space, and ultimately really create new economic booms.
And maybe explain a little bit about the potential benefits of expanding our manufacturing in space, because getting things to space is difficult, right?
Yeah.
So what could we open up if we really did have a big economy of additive manufacturing in low Earth orbit?
Yeah, so I think fundamentally, being able to do manufacturing in space of things like Z-band optical fiber, being able to do metal processing, being able to do bioprinting, these are like billion or multi-billion dollar opportunities. And those are just the ones that we know based on 30 or 40 years of NASA research and other folks doing research. We're barely scratching the surface of what microgravity in the space environment can do for manufacturing and for processing and for pharmaceutical research. I deeply believe that this is going to create an economic boom that is as significant as the e-commerce revolution. Coming from Silicon Valley, that's my one little shtick, line. But really, truly, that's what we believe is that moving manufacturing off the planet, for select materials at first, and then expanding out and out, is going to provide enormous economic direct and indirect benefit for our national and global economy.
Wonderful. Let's move on to Dick. And you manufacture here on Earth, but yep. The ISS is very crucial to what you do. So you specialize in small satellites. And I'm not sure a lot of people know, but the International Space Station is a great way for getting those satellites into orbit. So can you talk a little bit about that?
Sure. So Spire, we basically have a very large constellation of nanosatellites, 61 in space right now. Every single satellite of ours has all of our payloads all in one. So we track ships, we track planes, we track weather. But in order to get all those payloads into space, you kind of have to hitch a ride. And the way we do that is, actually the majority of the way we do that, so about 45% of our launches actually go through the ISS in some way. That's been that case, or it's been that way since the very beginning. Our first 3 satellites, ArduSat-1, ArduSat-2, ArduSat-X, were all satellites that went to the space station, got launched out of the Kibo module, which if you go online, you look up footage, it's probably some of the coolest footage you can see, and you hear the astronaut going, and the satellites have deployed. You get the best footage back, you get the best pictures back from the ISS. It's definitely something that we love to do. And so basically, by going up through the ISS, what you get is a very reliable, consistent way to get to space. Elsewhere, you're kind of dependent on, are you going to LEO or not? And the majority of launches that aren't going to the space station are also not going to LEO. So it's a really critical path for us to get there right now.
And yeah, so maybe you can expand on that. What are the benefits and the pros and cons of, do you prefer a ride share to the ISS deployment? How do you see those comparing?
Sure. So there are definitely pros and cons to each. The pros on ISS launches is reliability, and it's also sort of predictability. If you're launching food and water for astronauts, that has to get there. And so you kind of know that this launch isn't going to slip too much. There's kind of an issue in the industry with launch slippage. I think everyone who tries to get a satellite up knows that launches slide, and it can be months and sometimes years before they actually get up there. So in the case of the ISS, those are realistic pros, that your satellite's going to get there. Now there are cons, which if you're going, and it depends on who you are. So for us, if we're launching out of the Kibo module, we're going to get 9 to 15 months out of our satellite before it deorbits. Now, Cygnus has sort of taken that out by adding an orbit raise after they come off of the space station. And that gives us additional time for our orbital life for each spacecraft. So it's a sort of a best of both worlds. So you get a reliable launch, and you get a very sort of advantageous orbit. Now, what you get with other launchers is that you get maybe a bit of a faster timeline once you get to space. So if you go up with someone like Rocket Lab out of New Zealand, The day that you launch is the day that you deploy. If you go through the ISS, the day that you launch plus sometimes between a few weeks and a couple of months is when you deploy. So there's definitely a little bit of a trade-off there.
But I'm sure it's nice to have these multiple options for how to get to space.
Absolutely. Yeah. We like to say that we're launch agnostic. We take any ride that's going up. Our launch director, Jenny Barna, she has this amazing chart, which unfortunately I didn't dig out, but it's got all the launches going to space, and then it's got all the launches going to LEO, and then it's got all the launches that will take a commercial payload. And it's a very, very small sliver. And so we take anything we can get.
Yeah, great. So Mark, I'd love to go to you. Now, unlike my other panelists here, HP is not fully focused on space, isn't your full business, but you are definitely wading into the territory in a really cool way. So why don't you talk about the Spaceborne Computer that you've been working on that you sent up about a year ago now?
Yeah, correct. So I really like the introduction about how Silicon came to Silicon Valley. And a company called Silicon Graphics, Inc., SGI, was also founded in Silicon Valley, right down the street from NASA Ames. And so for decades, SGI and NASA Ames collaborated on supercomputers at the NASA Ames facility. And in 2014, NASA Ames said, on our mission to Mars, we're not going to be able to complete our Earth-based mission because we're so far away. We're going to have to take some of those resources with us. Can you help us do that? And they have NASA has a mantra, before we go, we need to know. And so we need to know, can we take a state-of-the-art, high-performance computer server into space? Will it physically make it there? Will it function properly? Will it give us the correct answers? And will it last about a year? Because that's how long it's going to take to get to Mars. So that's the three primary mission objectives we had for Spaceborne Computer. We took a system right off the factory floor. It's a standard server that's in data centers all around the world. No hardening, no prep other than software. Running an open source operating system. So those are the key things, a COT server and an open source operating system. We launched it in August of last year. And the majority of the community didn't think the computer would function at all, and if it did, it wouldn't last very long. So, okay, let's find out, right? Before we go, we need to know. We're now at day 345. We're 20 days before reaching a year in space. We've collected an awful lot of failure modes and failure anomalies that we've accounted for. The second part of the goal is to harden the system with software rather than the traditional long time, expensive process. And, excuse me, we've got 7 disclosures into our internal HPE Patent Council for potential patents having to do with that, taking that data center model and turning it upside down and making it local. The goal is, the high-level goal is similar to Made in Space in that he's taking a piece of machinery with some raw materials, and when a need arises, you'll use that machinery to convert the raw materials into something you need. So a Spaceborne Computer is a general-purpose Linux computer that can run any of the software that NASA Ames has developed to support the ISS mission. So you can think of it sort of as that raw machinery that we've proven can last almost a year. And you can envision on board of it, you would stuff it with applications that you might need. And as the need arises, you pull them off the shelf, put them into the computer, crank it out. And we discussed previously, you may want to do a CAD-CAM thing, verify the CAD-CAM, and then feed it over to Made in Space to build the piece or part that you might need. So the main objective is to make more of an earthly-like data center capability on our mission to Mars as we get beyond LEO.
And maybe talk a little bit more about the focus on software versus hardware hardening, because when I think about the space environment, I think, of course, you would need to harden it for hardware,
Right.
or harden the hardware first.
Right.
But why would we want to kind of downplay that a little bit? And you spoke earlier about how it's kind of making things more up to date for us, right?
Yeah, if you're headed to Mars, you probably want to take the iPhone 10 instead of the iPhone 2. So when we handed over Spaceborne Computer to NASA for launch, there was not a newer technology available. It was the latest thing coming off the factory floor. It came off the factory floor completely unmodified. Most of our effort has been at the software layer. So we've taken what is generally available in an earthly data center and placed that inside the computer system itself. So we monitor all the environmentals very closely, power, cooling. We monitor all the components very closely. And when they get out of range of nominal, we isolate them, work around them, or do something. So each of the systems is autonomous. It is self-sufficient with fault detection and isolation. And it's now up almost a year.
And how has it held up so far? Have you had any hiccups with the space environment messing with the computer at all, or?
Yes, there's a couple of humorous ones, and things you cannot plan for, things you cannot simulate, but things you can relate to. The first, what we call in data centers, unscheduled interrupt. That's a nice way of saying something went really bad. The first unscheduled interrupt occurred a couple of months into the mission. We'd been up rock solid for the entire mission, and suddenly, no power. We all have smoke detectors in our homes, and sometimes they have false alarms. There's smoke detectors on the ISS, and they have false alarms. But when one of those has a false alarm, the electrical fire is one of the suspects. And so they kill the power immediately. So that's an unscheduled interrupt. And of course, we went, oh dear, it's never going to wake back up, right? Pulling the plug on a Linux server is about the worst thing you can do to it, okay? But after power was restored, we went through our diagnostics, did our whole hardware inventory, did what we call a health check. It's a group of very extensive tests. And then we came back nominal and went back into production.
Oh, that sounds amazing. So I want to take a step back a little bit and talk to each of y'all about, why space? I feel like a lot of people might think it's a little too distant for them, or it's an unapproachable industry for them. Why did you feel the need to get into the space now, and how did you do it? Yeah, we'll start with you, Andrew.
Yeah, well, there's the little boy answer, which is I was raised on this steady diet of Star Trek and rockets growing up in Florida, and so that just seemed like this sort of destiny thing. But from the broader perspective, this is a field of amazing opportunity. It's a field, again, to use I think it's an apt analogy, being that we're talking about Silicon Valley companies. This is very much like the early internet. We have some amazing infrastructure, just like Amazon was built on the back of reliable payments and reliable delivery from UPS and FedEx, and being able to conduct business over the internet. We're able to build on the amazing infrastructure of commercial cargo and soon commercial crew, and of the ISS itself, and of the regulatory environment that's shifting to allow and to encourage more commercial activity, and really it's only fundamentally really existed with all the right pieces for the last few years, with the support of commercial activity on the International Space Station. That's something that that didn't have the fire behind it that it does now, 5 or 10 years ago. And so you're just now seeing the sort of first companies like us. We're fortunate to be one of those that are really pushing that. And we're grateful to the folks at NASA that have really made that possible, and we're also grateful to our brethren, our brother companies, and Nanoracks and others that, did a lot of the hard work so that we can more easily do the work. So yeah, I mean, there's just enormous opportunity, and really the time is right, and it's a really strong playing field, to be involved in.
And Nick, I think this is also a great question for you, because you are kind of capitalizing on the small satellite revolution right now. So at what point did you when did Spire catch on that this was going to be a big thing, and how did they really capitalize it?
Well, so it's kind of funny, because from day one, the way we've always kind of looked at the world is that when you try and track things from the ground, you end up actually only tracking areas that have people in them. And when you track things from space, you get a more complete idea of what's going on, in particular on the oceans and in very desolate areas. People, we travel from New York to San Francisco, and we go from San Francisco to London, or even to Tokyo, but what we don't realize is how much stuff is in the middle. And even when you're flying over the US, you see that there are big swaths without hardly any sort of human impact happening on them. No power lines, no cell phone service, no connection of any sort. And we're a developed country. So when you look at Spire and the way we kind of have leveraged this revolution, it's been all about, from day one, to provide global data in a way that is just not possible from the ground. And that's also how we look at it economically. People have come to us and gone, hey, why don't you put this sensor on your spacecraft? And it's something like tracking trucks. And it's well, trucks always have a cell phone connection because they're almost always near power and internet. So you're not going to track trucks across the US from space, but you would track planes after the MH370 disaster, because a plane flew right through a major hole in coverage. So I think to answer your question, the applications are what is kind of driving all of this, not necessarily the technology and not necessarily always the access. It's very much driven by a really strong desire to, this might be a little bit cliche, but make the world a better place.
That's great. And Mark, as well, I mean, did you feel like there was some hesitancy to get into space, since you were mostly focused on computers?
Right.
But
Right.
What was the inspiration to wade into this area?
So our CEO has a phrase, customer first, customer last. And NASA Ames is one of HPE's largest customers now that they've acquired SGI and continue to maintain that relationship. And when one of your largest customers says, you've been supporting our mission for decades, and our mission is kind of morphing, we're going to need support as we go to Mars, then we kind of got on board with that. So we don't benefit per se, and we support our customer in their particular mission.
Gotcha. And you touched on this as well, the applications. How would you say that what you're doing, what's the most tangible effect that it's having for people here on Earth, and how would you explain that to them?
Oh, for us in Spaceborne Computer?
Yeah.
Absolutely. So I think it's been written that whenever you write software, your natural biases get into that and your natural assumptions get into that. When you write software and send it to space, you learn about all those biases that you placed into that software. And in that harsh environment, you learn how to write some software that can prevent further damage and interruption of processing, et cetera. So again, those 7 items I talked about that are potential patents are things that could come back down to Earth, be implemented in stock factory available systems, and provide for all of our customers worldwide more reliable and more robust servers.
Oh, great.
Yes.
So space could give me a faster computer.
Yeah. Faster, better, stronger. Yeah.
All right, great. And what about you, Andrew? You talked a little bit when you during their first question, but if somebody asked you, how is manufacturing in space going to help me right now? What would you say to them?
Right, right. Well, there's some really immediate term benefits, and one of those is that in developing a 3D printer that could survive a rocket launch and then operate in space without a technician going along with it to tune it up, we made this really reliable and robust piece of equipment that not only can work in space and work on the ground, but it can also work like on a ship that's at sea and moving around. So we've by developing this printer for one of the most extreme environments we can think of, we're able to have we've created a technology that's hardened for other extreme environments, like naval vessels or submarines, or or even bouncing around the back of a truck, in a humanitarian aid regime. So that's like a really immediate term way, and then the sort of medium and longer term ways are, as we're able to develop these new processes and materials that are space enabled, there's not an economy in space for us to sell those. We're going to bring them back down to Earth, and we're going to make great product. We're going to lay transatlantic lines that are that have better response time and more bandwidth, and there's a wide variety of other applications that are gonna help slake the thirst for the thirst for more bandwidth and provide better telecommunications here on Earth. So
basically, what I'm hearing is it can survive in space. It sure as hell can survive here on Earth. Right. And also, Nick, what about? You talked about some applications already, but how? I feel like Spire has a much more direct impact here on Earth. So what are you guys doing with your satellites, and how are you helping the infrastructure here? Sure.
So there's three main, or we'll call it four main products that we're working on. The first one is maritime. It's a ship tracking product. There's a lot of really cool applications to ship tracking that we nerd out about. One of them is like its effect on the food supply of the world. So we've got a partner called Global Fishing Watch. They're a customer of ours. They take our data along with a whole bunch of other data sets and determine whether areas are being overfished. And basically they're not the police, but they're kind of the detection of problems in Earth's protein supply. So that's like a really amazing downstream application from us that we never thought about even from day one. There are also implications for things like piracy and human trafficking. So, for instance, in the case of these illegal fishing vessels, what they'll do is they'll essentially double fish. They'll fish, and then they'll unload their catch to a boat, like a refrigerator boat that's going somewhere else, and then go back and fish the same spot again. Then go back to their port and say they fished once, gotcha. which is really bad. There's the government of Indonesia actually takes those ships, and once they catch them, they actually blow up the ship. Not with the people on it, but they actually got sick. I believe what happened is that they got sick of these vessels ending up going right back to what they were doing, and boats are pricey. So they blow it up, they take lots of pictures, and they make sure everyone knows this is going to happen if you break the law. Now, it turns out that these illegal practices, either piracy or illegal fishing, actually have direct ties into human trafficking. So by shutting down these other illegal activities, you actually put a dent in human trafficking. So there's a huge impact to stuff like that.
Wow.
Yeah.
Sorry, Nick just blew everybody away. Yeah. I forgot to mention earlier, we're going to do a Q&A session after this, and so you can submit questions if you want through the conference app. So we'll do that in, I guess, 20 minutes or so, but we'll keep talking because we're having a great convo. So there's been a lot of talk about the future of the International Space Station recently, and I believe a couple weeks or months ago, NASA's Inspector General said there might be a lack of interest or enthusiasm, not good business cases for working for companies to work in space. I'd love to hear your thoughts on that, having built a business case on space.
Well, I would respectfully disagree with that notion. Yeah, to kind of continue the point I was making earlier. Like we have just started. Like the groundwork for seeing if there is a there, and for avoiding a false negative just now exists. And we're very proud to be one of multiple companies that are, that have built profitable businesses that utilize the International Space Station, that utilize a platform in low Earth orbit. And I think that we need to be realistic about timing. I think we need to be cognizant of what are weak and strong signals that say this is growing. Because if we talk about direct federal funding ending for the International Space Station in 2024, I can be optimistic, and I can say, yeah, I'm going to be able to be an anchor tenant of a commercial platform, by that time. I'm an entrepreneur. That's like part of the DNA of what we do, right? We'd be optimistic. But if we step back and say, okay, what are the other 6 models that you build and update on a regular basis, and what do they say? Well, they don't all say that. But they also say there's a there there, and we're steadily working toward that, and we're not the only one. So we have these signals that say, hey, there is enthusiasm, there is a commercial sustainable market here, even just in the fact that there are every year more companies, not fewer, doing commercial activity on the space station with an eye toward doing it in a way that can be sustainable, at current launch operation return prices, and can be sustainable on commercial platforms. Mm-hmm. So, yeah, I think that we're just starting out, and I think there's been some pretty significant strides, especially considering the overall infrastructure that the space industry. When we say soon, we often mean 2 years. Mm-hmm. Every other industry, when you say soon, we often mean 2 quarters.
Right.
So we've seen significant progress even just in the last couple of years.
Nick, do you have thoughts on that?
Yeah, I mean, so many of our launches go to the ISS in one way or another, and I think that's a pretty good case. And we're certainly not going up there for free. No one there are free rides to the space station as student payloads and whatnot, but commercially we're not going for free. So there's that commercial aspect. I think that the part that kind of gets lost in this conversation is the idea of the International Space Station as an incubator. And I think there's 2/3 of this group here kind of I won't say we were made by the International Space Station, but it was certainly a significant part of the start of our companies. Mm-hmm. Like I mentioned, our first 3 satellites went through there. Our first 2 satellites were essentially experimental satellites, and I don't think they would have gotten there any other way. I think they would have gotten there another way, but it certainly wouldn't have been as easy, and we wouldn't have had the support of NASA and the International Space Station, and it would have been it would have produced significant roadblocks, and so and I know that we're not alone. There's sort of countless companies. I mean, you might be able to count them if you're someone at NASA, but so many companies have gone through what we went through and tested components on the space station, or got CubeSats up there that otherwise wouldn't have gone up there. We've got former students who now work for us who had CubeSat payloads that went through the International Space Station. Those people might not be employees had that not happened. So the commercial implications of the station go far beyond what we pay for a ride up.
And I'm very interested to hear from you, Mark, too, because...
So I may have a bit of a different perspective on that. So, I mean, we're in San Francisco, and one of the things San Francisco is known for is the gold rush, and all the miners going out there, and the people you're talking to and about are like the miners. Are we a Delta faucet that can make the showers better? Are we a Goodyear tire that can make our tires better? Are we monitoring the bad fishing guys, right? We're a computer company, and we're very good at equipping national labs and R&D data centers with IT infrastructure. So we're showing that we can have some IT infrastructure that is reliable in space. And we think if we can relieve that burden or relieve that hesitancy and give the gold miners there the belief that they'll be able to buy Levi's and shovels and picks and have a data center that's functioning, then there may be more space explorers. We have a phrase in the computer science side of the house that we want the scientists and engineers to work on science and engineering and not computer science. And so as we show that your computer science is rock solid and available, then hey, maybe more scientists and engineers will take the step.
Gotcha. I'd also like to expand on this because we are talking about the future of the International Space Station, and there's been a lot of talk about transitioning the capability and the domain of low Earth orbit to the commercial sector. How do you see your companies fitting into that future? Do you see, how do you see your, playing in that field, and what would that look like to you?
Yeah, I think from a broad perspective, we're supportive of a capability-based transition for the International Space Station. We are extremely supportive of seeing that there be no gap between the International Space Station and successor platforms, successor commercial platforms in low Earth orbit, because a gap will snuff out so much of the progress that so many companies have made and will make. And we're one of those companies that the International Space Station, as was pointed out, is an amazing incubator that's let us make these small bets, and now we're scaling those, and we want to scale those as quickly as possible so we can get off the ISS. And once we can, and getting off the ISS means multiple things for us potentially. Whether that's a sort of a dedicated flight, like a Dragon Lab or a Dream Chaser flight, or being on a Bigelow module or an Axiom module, or Independence One. We're adaptable to all those. We're what's a platform agnostic, to borrow a term. But if ISS, if we don't have that capability-based transition, then people like us that were incubated and that have grown are going to have a much harder time of it. And while we want to, we are ambitious enough to want to be the big dog in this burgeoning economy, we don't want to be the only dog. We want there to be lots of shots on goal. We want there to be lots of successful companies. And I think that this sort of crawl, walk, run process that the ISS enables is what we want to see that continue. And if there is a smooth transition, I think that'll work. And if we can also, have more, fire behind supporting the demand side of things, then I think that will help ensure that those commercial guys will have a sustainable business. Because at the end of the day, they want creditworthy tenants. I want to be a creditworthy tenant, and I want a whole bunch of my friends to be that too.
I think that's something really special about the space industry, and I hear that from everyone, is everyone welcomes competition in other players. You don't really hear that very often, but everyone has the same feeling about it. It's that it's good for the industry.
Yep. Space is a team sport.
A team sport. I love that. Nick, what about you? Do you see yourself deploying from a commercial space station someday?
That could certainly happen. Like I said before, we're launch agnostic. We don't really care.
Yeah.
What we care about is that you've got a good price, you're going to an orbit that we like, and that you can get us there in a reasonable amount of time. I haven't done a recent count on how many different launches we've done, but we've done launches from more than I think 7 different rockets. So it honestly, if there's a nice transition to something else, we'll take that. For us, we're also keeping a close eye on what the commercial industry is doing in terms of small satellite launch providers. Obviously, Rocket Lab has had one successful launch so far, and Virgin Orbit is right on their heels, as are some others. And so we're kind of keeping a close eye on that, and also what other people are doing in terms of ideas for sort of HABs in space and that sort of stuff. Like there's a pretty incredible amount of ideas, and we're just kind of watching to see which ones are executing the fastest and how we're going to be able to leverage those.
And you talked specifically about sending the Spaceborne Computer to Mars. What are some other applications that you envision for computers in space? Do you see this being on a tourist flight or something?
Oh, sure. I couldn't agree more with the other two panelists about being agnostic. And our business model, if you would, is we sell computers to national labs and universities and R&D centers. And what we noticed is the next guy to buy one wants something bigger and better than the previous guy, right? And we'll sell to all the universities and all the labs, et cetera. So if we have this capability to ship the latest and greatest off the factory floor, and it survived your mission, then yes, we want to go into something other than low Earth orbit, like you say, a reservation system aboard an orbiting hotel, right? You probably can't take the ones you're using today. You might want to consider one that's been proven in space, available on Earth, is a phrase that we're using today. Also, there's concepts for a lunar base, and there's a lunar gateway. So, yeah, not only Mars, but these other locations are where we think this IT infrastructure could help the scientists and engineers be better explorers.
Okay, interesting. Kind of expanding on what we're talking about a little bit, I'd love to know what you think are the biggest challenges facing companies, maybe even those in Silicon Valley, from getting into space right now, and what you would think is the best way to fix them, Andrew.
Yeah, I mean, the fundamental challenge of the aerospace industry is that space is hard, right?
Yeah.
It's I think Mark made a good point earlier that we have all these assumptions. When we design things for Earth and then we go to space, and it just turns out so many of them are not applicable.
Yeah. And the only way to test is to go there.
Right. And so that's a great challenge is having that ability to go and test, which is again which is why platforms like Leo are so great, because we can go and whether it's a component level test or a prototype satellite or a prototype manufacturing facility, we can go and make a small test, make a small bet, see if it goes, and then grow. And that's actually really amazing from a new entrant, from an entrepreneurial perspective, because if you look at sort of traditional VC funding, like your seed rounds, a couple $100,000, maybe $1 million, and your A's, a few mil, maybe like maybe 10, and then on. And now we can actually fit space into that model and say, it used to be, for the low price of $20 billion, I'll do this amazing thing for you in space, but if you give me $10 billion, I can't do anything. But now it's, hey, I can start small, I can start with a few $100K, and then if that works, I can go more and more and more. And so that was previously a really big challenge, I think, but now both from a launch perspective and a satellite perspective and space-based operations perspective, we've seen that barrier fall away.
Nick, what about you?
I think, as a company, we've had a lot of technical challenges, but I think our biggest challenge, sort of all time, tends to still be people. No one sitting up here competes directly with each other, but when it comes to engineering talent, I think we might say something completely different. If you go to any of our websites, you're going to see job listings for engineers and software engineers and scientists, and these people are tough to get. And even in Silicon Valley, where we think of this as being where all of the engineering talent and where all the software talent is, we've found that opening up offices internationally has been the best way for us to bring in more talent, because it's tough.
Mark, let's talk to you, and then we'll open up for questions.
So I'm certainly not an expert in the impediments to space exploration, but I do know that wherever I go and all the customers I talk to, regardless of the business they're in, they always have an impediment to progressing their business that's related to the IT infrastructure. Okay, so that's where we're focused. And we have one customer, NASA Ames, that saw this problem coming years in advance, and we're taking the incremental steps, like you say, maybe a 2-year, et cetera, step in that direction. But everyone coming to the space marketplace will have those similar challenges, and we want to help remove that impediment if we can.
Wonderful. All right, well, I'd love to hear from all of you. Like I said earlier, you can submit questions through the conference app. So let's go ahead and get started. I think I'll have them on the speaker.
Hello.
Yeah.
All right, I think I got volume now. In your opinions, how should NASA address competitive commercial proposals, noting that there's limited resources for ISS in space?
Yeah, I didn't catch that last
I didn't
bit.
catch it, sorry. Can you say that again?
The question is, in your opinions, how should NASA address the competitive commercial proposals, making choices between proposals, noting the limited resources of the ISS?
So how should NASA address the commercial proposals, competitive commercial proposals with limited resources? Anyone jump in?
So I think that's a pretty broad, that's a broad waterfront that we can cover with that. And certainly I think a lot of the ways that NASA handles competitions are very strong and you know, are well trod. You know, in terms of, you know, to the extent that we're trying to encourage, you know, a commercial transition and commercial activity, I think it's important to look at both technical chops and business chops, and say, you know, okay, like technically you're rational and we believe in your team, but you know, from a business perspective, like, you know, is this rational? Like, you know, is there a crawl stage and a walk stage and a run stage, and depending on the level of investment or the level of resources dedicated by NASA. I think it's wise to have some opportunities to pull the ripcord to you know, to say, hey, we're gonna step back from this and go in a different direction, and you know,
being a little more selective.
Well, I think it's managing risk and saying, you know, looking at the business and looking at the technology, and then but also trying to move quickly, like trying to make those decisions quickly. I think is really important. Because we have an asset that has a finite lifetime, whether it's 2024 or 28 or 32 or what have you, that there's a finite lifetime to that. So some of the more traditional pathways of, you know, like SBIR, which we're great fans of, but that has a more extended timeline. That might not be the best timeline to, you know, to bolt on here.
Right. Anybody else want to jump in on this?
So I'm actually a fan of, I think Adam Savage said that NASA is ridiculously rigid and has formalized failure, something to that effect. I'm actually a fan of their selection process. It seems to be fair and open, and I don't know how we would improve it without additional assets. Again, our project was accepted. But several months into the project, I quickly learned that if the word you get back from NASA is, no, we can't do that, then you need to accept that no and move on a different route, that they know what they're doing. And if you want to spend a lot of time and effort figuring out why you got the no, you can, but it's still going to be a no. So we just moved on. And keeping a focus on the mission and the customer and the desired results.
I don't have much to add to that.
All right, next question, please.
All right. Would you consider being an anchor tenant for a new commercial space station, and what are the top 3 capabilities you would need?
Yes.
What was the question?
Yeah, sorry, I'm having a hard time hearing a little with the echo.
The question is about being an anchor tenant, and obviously the answer is yes. But they're then looking for what are the top 3 capabilities you need in that commercial station to.
So basically, we're building our own perfect space station. What would you want?
Okay.
How would you outfit your house in space?
Right. So yes, would love to be an anchor tenant of a commercial platform. I think that you know, like a home or a business, you know, we look for a few things. We look for We look for the appropriate amount of the appropriate amount of volume. We look for reliable power. We're growing up on the ISS, so we're used to talking in terms of like 500 watts or a couple of kilowatts. As we grow, and once we get to like really large scale manufacturing, those power requirements may grow but we're always going to be cognizant of trying to keep those low. But the other thing you look for with a business is good traffic flow. We need consistent launch, operation, return. With station, we probably have about 3 or 4 flights. Two on lean years, and a few more in other years, but call it 3 or 4 flights that go up and come back. If that doesn't exist in a commercial platform, that's something that's going to be a challenge for us to adapt to. And then maybe the final part is we design our systems to not need human interaction, to be fully robotic. But obviously, having a person there, having the opportunity to train that person, or maybe in some regimes having the opportunity to fly a mission specialist who I train and who's a really amazing glass scientist, is also a really big plus.
So in terms of commercial crew and commercial cargo, those things could be very beneficial for a commercial platform in the future.
Absolutely. I think those are fundamentally enabling.
You talked about space, but I was thinking the other day how New Yorkers probably would be great tenants of commercial platforms in space, because I've lived with very little space for such a long time. Nick, would you like to add on to that?
Yeah, I'd love to see more than one commercial station and in more than one orbit. I think the standard of having resupply missions works really well with our business, but I'd love to have more locations on resupply missions. So maybe something in a polar orbit and something in an equatorial orbit. It'd be great to have 2, 3, 4 stations. One, competing with each other on how fast they can deploy our CubeSats, and 2, competing with each other on sort of uniqueness of the orbit.
Right. Again, the more the merrier.
Exactly. Exactly.
I thought I wouldn't have anything to say with this, but hearing these two, there's quite a few analogies. When I visit national labs and R&D data centers, they all need the same handful of things: more square footage, more power, more cooling, and you mentioned the regularity of traffic. We call that technology refresh. So instead of planning on this thing to last 20, 25 years, et cetera, let's plan on refreshing it every 3 to 5, like all the rest of our national labs. And then you brought up a second floating lab. We've got quantity 1 in space, whereas our national labs in America today have a focus, and we have multiple national labs with different focus. So again, they compete for the dollars, they compete for the customers, and that competition is good for the Earth-based national labs. It would also be good for space-based labs.
Yeah, I can imagine that a station in a polar orbit might have a different purpose than a station on an equatorial orbit.
Yeah.
All right, next question.
Okay, there's a couple of more specific questions. In terms of CubeSats, do you see Cube satellites as something that will continue to gain further traction? Why or why not?
Well, I think that's for you in the middle here.
I think the answer is definitely yes. If you you map out the number of launches of CubeSats and the amount of CubeSats deployed over the last 10 years. 10 years ago, it was essentially 0. Today, with a little hiccup due to not having available launches, things have grown pretty much exponentially. I don't see that stopping anytime in the real near future. If you do just a quick cursory search on the word CubeSat in Google Scholar, you see that there's quite the trend for more and more and more research, more satellites, and more commercial constellations. Commercial constellations are really the big one. As these commercial constellations like Spire get built, we not only are putting up up to 150-ish satellites, but we also have to keep refreshing those every 3 to 5 years. As you put up another constellation with a different company, they then have to do a similar cycle to refresh their satellites. And so the CubeSat thing, I don't think it's going away, at least not anytime soon.
Maybe you could expand on that. What are some of the benefits of CubeSats that big bus-sized satellites don't have right now?
Well, so you're able to get full global coverage at the cost of 1 to 3 large-sized satellites. So you might spend a whole lot of money on 1 to 3 satellites where you get pretty good coverage, say over a particular region or over a particular orbit. With CubeSats, you get global coverage with a very high refresh rate, so going over the same point over and over and over every day, but at a similar cost. And it's also very well focused on sensors that fit into that CubeSat size. Stuff like AIS, which tracks ships, or GPSRO, which reads weather signals, or reads weather by sort of doing computation on GPS signals. That sort of signal-based intelligence is very sort of tuned in for CubeSats. However, there are, like, the more active technologies, people are just now starting to put radar. I think there's a satellite that launched a couple weeks ago that put radar on a CubeSat. It was a 6U, not a 3U like us. Those things require a lot of power. So anything that has a heavy power requirement or has where the size of the sensor, so like optics, is probably going to have to stay on a large satellite. Optics is a weird one because the size of your lens and the size of your sensor matters so much. With a CubeSat, you simply can't get the reading a newspaper ground resolution that most companies are looking for.
Anyone else have thoughts about
Is
this?
up mass also an advantage?
It is, yeah. I mean, so you kind of factor it into the equation on how many you can launch, and so like the mass very much affects the price of the launch. So a lot of times people measure launch in kilograms in terms of price.
Right.
So.
Okay. We've got a couple made in space kind of focused questions. What has the demand been from potential partners for on-orbit manufacturing so far?
So the question is, what's the demand?
What's the demand been so far?
Right, for on-orbit manufacturing. So that's a very good question. And I'm going to kind of break it into 2 or 3 different categories. The first category is we'll call it crew-focused manufacturing, which is, right now what we're doing is manufacturing, various objects and parts that are used on the International Space Station, or are, to demonstrate capability that we can do manufacturing for future missions. That's been going on since the first printer was launched in 2014. That was a printer that was that NASA owned and we operated on their behalf. And then we launched a commercial printer in 2016. And that business has, that line has been, sustaining itself since then. We're coming up on 200 parts manufactured in space, which is kind of cool.
Yeah.
One of the bigger limiting factors with that is actually waiting for an astronaut to come take the part out of the machine, which we are grateful that they do that.
What are some of the tools that you've made?
So we've made, one of the ones that I really, really like was they have these radiation sensors inside the beam module. And we made these kind of we made these varying geometry covers for them to basically study with different geometries, how they would serve as radiation shields. And there were some interesting results from that and some potential follow-on there.
Cool.
So things like that.
Yeah.
So the other 2 categories are in-space manufacturing of satellites, and that's an area of really huge promise. We have we have both commercial and government customers for that. Some flight hardware, and then we have a big flight demonstration that we hope to do for NASA, kind of coming up.
Yeah, isn't that in the next couple of years, right? Or?
Yeah, so we've had about 2 years of ground development for Archanaut. That's our in-space manufacturing assembly technology. And this is really transformative because it lets us, let's us take all those pieces that we kind of traditionally origami fold up and put in the top of a rocket fairing and actually just manufacture and then assemble from prefab components those things on orbit. So we can optimize them for their operational environment rather than designing them just to survive launch.
Yeah, that brings to mind the James Webb Space Telescope, because that is so massive, and the unfolding process for that thing I think takes weeks.
It's like about a month, actually.
Yeah. So maybe you could, is that a possibility of creating a telescope just as is?
Yeah, that's one of the sort of long-term, like real solid goals that we have for the technology, is being able to build these like large optical class assets. Because as we've seen with James Webb, I am so excited to see the imagery that James Webb will one day reveal to us, and the science that we will discover, that we will uncover, not unearth, but uncover because of that. But really, the sort of cost of those assets, I think it's like the cube of the diameter or something. It goes up. It's wild. But in-space manufacturing assembly really kind of breaks that paradigm and lets us do this in a more cost-effective way, so that one day we can put 15-meter mirrors up or 30-meter mirrors up.
You'd make a lot of scientists happy with that.
Yeah. It would be a real exciting time to work on that. So there's a lot of activity there. And then finally, on the kind of what we call the space for Earth side of things, the space-enabled manufacturing, we've been very focused on building our pilot facility, proving it out, and starting getting some really good results from that. We haven't done a significant amount of marketing of the product, but we get like cold inbounds from people saying, "Hey, I saw this article. I have this application, and I would like it. When can I have it?" And we have other customers that are like similarly very excited about it. So, it's early days, but we think there's a pretty bright future.
All right, we have time for one more question, I think. So, is there something that our whole panel can answer?
Okay. Yeah, I do have a more broad topic question, which is, what do you believe is the ISS's role in propelling the space economy?
Well, I think that's a perfect ending question here.
Repeat the question.
What is the ISS's role in propelling the space economy?
Oh.
I think it's the linchpin. I think it's the linchpin of us creating a low Earth orbit economy, and if we can use it, and we will both from a national perspective and a global perspective repay the cost of building and operating it just multiple times over, and I think we just don't even know the depth of what that kind of boom will be. On the other hand, if we let that slip, we're probably looking at another couple of decades before we of really pushing hard to get to the same spot. So yeah, I think it's the fundamental enabler.
Yeah, I mean, Nick, I feel like Spire owes a debt of gratitude to ISS in a way.
Yeah.
I mean, how many satellites would you have without it?
Well, so that's actually tough to say. I think I can't discount the drive of our CEO. I think he would have had satellites up there hell or high water. So that's a really tough number. But what I can say is I definitely agree on the idea that the ISS is a linchpin, because I think no one would be going up if there wasn't access to space. Access to space is essentially the key driver here. The percentage of our launches, the percentage of experiments that reach space, the ISS is probably the #1 producer there. Actually, it's not even probably, it's definitely the #1 producer there. So along the same lines as I said earlier, it's an incubator, and it's also the access point. So if you delete the incubator and you delete the access point, what you're left with is actually kind of sad.
Right.
Mark, do you want to finish up?
It's been documented hundreds of times how much things come back to Earth from space exploration in general, you know, Velcro and yada, yada, yada. So, but from us, the linchpin is NASA and their mission, right? So along with the ISS, and in agreement with my other panelists, I think that it is crucial to have a mission and to move toward those objectives. And just like many other things in history, aircraft started in the government, and now we have the airline industry. Space travel started with the government, and it's now going commercial. I think that's a common trend, and the incubator word is perfectly aligned there. And we're going to grow to that, what, 2.7 trillion over the next few years, as they said. So I'm looking forward to that.
All right. I think that's a great note to end on, and I want to thank all of my panelists for being with me today. So,
Thank you.